Welcome to Module 4 of hor166. This is probably one of the longest modules, so I'm going to break it up into quite a few small videos. This first video is going to be an overview of the soil testing and then a virtual tour of the soil testing lab at North Carolina State University. But I want to talk a little bit about this picture. This is probably the part of soil testing or fertilizing that you've all partaken in. The heavy lifting part, but what we're going to talk about here is the why behind the heavy lifting in soil testing. So, one of the most important parts of any good agronomy program is the soil test. In order to get good turf, we need to do a few things, and this slide will summarize that in a lot of ways. First, we're going to talk about in Turf 1 the proper grass species. If we don't pick the right species for the macroclimate and the microclimate, we're doomed to failure no matter how good the soil is. Then we need to give it what it needs, and we do this through fertilization, and we do it through the photosynthesis equation through sun, and we've talked about that quite a bit, so you can review the photosynthesis equation. And this is the part that we're going to talk about in this whole lecture, giving the plant what it needs. And what is that? And also proper maintenance. So that's the part you guys all like, and the part you're going to learn on your internship is getting the biggest and the best mower out there and maintaining stuff. But the brain stuff comes kind of in here in the selection a lot. We don't have much choice of that. And this is really what is going to distinguish you as a golf course superintendent, is doing this better than everybody else, more efficiently, more cost effectively, etc. And then this is another component of that, and probably the component more that you are involved in right now as a laborer. So ultimately, we are going to receive a piece of paper from the North Carolina Department of Agriculture. Amazingly, this is free. That causes some problems because it might be overused by some people. There's a move afoot to take soil samples every 10 feet, and even some golf courses are starting to do that, and that is useful, but it's expensive for North Carolina. But I'm going to show you how to take an old hand soil sample, and I'm sure some of you will be involved in this microsampling that we call it. And we'll talk about that a little bit as we move forward. But ultimately, each box of soil is going to yield a series of numbers. And we're going to, in the next series of videos, not this video, tell you what all these numbers, what CEC, base saturation, pH, PI, calcium, all of those mean, and how to interpret those to get this. So this is kind of the dummy approach. It's going to say, this one says put no lime, use 20 pounds of 5-10-10. So this spells it out. That's pretty good, but there are reasons to go against that if you understand the lines and actually what's coming from the soil testing lab. We need a soil probe. This is probably not giving the plant what it needs. This is what it looks like when somebody has Roundup on their shoes and decides to walk on a putting green. But we will need a soil probe. Hopefully we will have clean shoes without Roundup on them. Collecting samples, you want to take between 15 and 20 samples to a uniform depth. It's important you use a plastic bucket. If you use a metal bucket, that will change the results. And you want to use your head thinking about, do you want to be 3 inches or 6 inches? What species are you using? How deep are the roots? Justify that with your brain is probably the best way. If you have a field, this would be a crop field, and one area is eroded and has a different color, another area is normal and has a lighter color, and this area maybe has all kinds of sedimentation or is different, or the grass looks different, you would make 3 samples. You would take 15 samples from this area randomly, 15 samples from this area. Mix them into a bucket, put them in the container, and send 3 samples off if this were your field. The more samples you take, the more information you have, the more time that takes. So it's a cost-benefit analysis. You can go and hire hundreds of people to come take soil tests every 10 feet. If you like, then interpreting the data becomes a problem. There are computer models that do that. There are fertilizer trucks now that will adjust to that and practically drive themselves. So 15 to 20 samples per each area. How deep? 3, 4, 6 inches. Mark your probe. Be consistent. Probably shallower for pasture and turf than field crops is what this is showing. So 4 inches is probably good. A lot of your results will come from that top layer. It all should be within the rhizosphere, so it all should be within areas where there's roots. So there's your plastic bucket, not a metal bucket. Once you put it in the bucket, mix it all up good, and then put a sample they like you to fill. There's a fill line on the box. Pour it into the box, fill it, make sure everything's labeled properly. Make sure everything's labeled properly on your sheet, which is this sheet here. The grower's name, address, that would be you. If you're sending it to somebody else, that could be me. Oftentimes for class, you'll put my name on there so I get a copy of it. What's the label number? Your sample identification. You leave that one blank, actually. That's what they're going to put it in their number. You make something here, like I might put MV, Mike Ventola, front yard 1, FY1, something that you can remember. And then the crops, make sure you fill everything out, what you're going to use. The list of crop numbers are on the back. By putting in the proper crop numbers, you'll get the proper recommendation from the proper scientists. Again, if you understand this very well, this becomes less important because we'll get the actual raw numbers on the sheet also. So, this is an important definition. It's a definition that's wrong in Wikipedia, and we've had some problems with that. Agronomy, something I have a master's degree in, is soil management for crops. And one of those crops can be turf grass. But the important thing is the soil management, the study of the soil and what we can give to the plants to have better crops. Turf grass is one of the most difficult crops, and I'd like you to think about that, and we can discuss that in class as we move forward. And one thing you should think about is how often in field crops, in an annual crop, you get to till the soil, and how often in turf grass do you get to till the soil. And how hard or easy is it to get to incorporate materials into the soil. So, as we move through to prepare our soil, the initial step prep is the most effective time to add fertilizer, lime or OM, which is organic matter. Removing the topsoil, making our proper grade, getting it smooth, putting the topsoil back. This is important. If we don't remove all the rocks and stumps, we can have disease later, we can have dry areas later. So the time spent in soil preparation is very important for any turf area, from golf course to athletic field to home lawn. It's very difficult to get a good stand of turf grass on subsoil, soils that are very much lacking in nutrients. In this profession, you're going to be out there with a shovel. That's part of it. Final grade work. There's some of our former students out there working. Sometimes you'll get a bigger shovel than others. This is the step of they're taking the topsoil, they're stripping it, they're piling it up. They'll grade the golf course and then they'll move that back with dozers or with great big pans. So you can see that some of the reasons some guys came to this, construction is a fun part of it. It's on many different scales and much different equipment is used for that. In the most extreme cases, the USGA putting green, we remove all the soil and add our own soil. The pad athletic field is also like that, or the 12th hole at Augusta that has even piping underneath for hot and cold water and lights. So we can spend a lot of money to get what we want, and we can get it if we know the proper agronomic principles. Here's a schematic of the USGA putting green. Basically, it's a completely man-made soil surface, almost like a pot, but on a much bigger scale. There's gravel at the bottom, and then 12 inches of mix, which is brought into the site. There's the 12th at Augusta. This picture's a little bit out of sequence, but this is a picture from the green back to the fairway. But as you can see, this green gets very little light. They have lights they pull out onto the screen. Here's a picture of you can see the layout of the hole. There's the tee. Players play to this very narrow green. That's why it's so difficult. This bunker's a problem. The water's a problem. Actually, lots of balls get lost here in the back, but there's lots of great big trees and azaleas, and no light ever really gets to this green. So to keep grass on it, they have lights that they pull out and give 12 hours of light a day. Here's a USGA green. You can see that they have removed 16 inches of soil, put 2 inches of gravel, and then 12 inches of mix goes over the top of that. So this is a completely artificial medium. It's mixed off-site and brought in. It's sand mixed usually with peat moss. Here's a picture of the PAT field, the Purdue Athletic Turf. It's basically a USGA green for a football field. It cost $125,000 in 1975. It's been redone a few times, but this was Purdue great land grant agricultural school's answer to artificial turf. So, to the soil test. Once you send in your soil, it'll be treated, ground, and sent to get your soil testing report back. You can see North Carolina has one of the widest ranges of soils, colors, from a sand, coastal plains, to some of the darkest Piedmont soil, red, dark red, clay. There's the outside of the building. We've been there on field trips before. You might get an opportunity to do that. That's probably a worthwhile thing, but we're going to give you a virtual field trip here. You won't have to spend 4 hours in the van going to North Carolina, going to Raleigh with George Thompson, although that can be a learning experience in itself. You will get a chance to ride with George Thompson somewhere, most of you. There's the lab. You can see hundreds and hundreds of soil samples day after day. They all start here. This is the grinder. So the soil is dumped into this grinder, and it comes out back into the box. So it's made to a uniform size and a size that will dissolve best for the analysis process. From there, a mild acid is added to the soil, and it's made into a solution. So that's soil solution that simulates the soil solution you would get in the soil as best possible. The soil solution then goes to this machine. You can see in here there's a flame. This is called a flame ion. Spectro is light. Photometer. Photometer is measuring the photons. And what this does is this little machine comes over, takes a sample of the soil solution. It runs through this tube into this flame and burns. While it burns, there's an electronic eye that measures the color. So that's the flame here. Ion, spectro, is the burn, makes the ions make different colors. The spectro is light, and photometer measures the photons to tell you how much of each element is in that soil solution. Pretty amazing, speedy little gadget. Goes pretty fast. Does a really good job. And these probably $300,000 machines that can run thousands of samples in a day. So that's the flame ion spectrophotometer. I will not ask you to spell it, but it's probably a decent thing to know for your quiz. The other part of this, the part that's not yet fully automated, but they're working on it, is pH. And pH is probably as important as all those other. You're going to get about 50 to 100 numbers from the other flame ion spectrophotometer. We won't look at all of those because they're not important. However, we will definitely look at pH. And the pH is the measure of the alkalinity or acidity of the soil. And a pH of 7 is neutral. As pH goes down, the acid level goes up. As pH goes up, the base level goes down. And we need a certain range, or it's important to have a range between 6.5 and 7.1, which makes more nutrients available to the plant. When soils get off on pH, nutrients get off and we get deficiencies and many, many problems. So liming is one of the first things that you want to test, and even to the point where soil pH testing on site is useful. You need to get that, particularly in the establishment phase. And then over time we can monitor our changes for how they're affecting pH. Lots of different soils in North Carolina. Lots of different results. We have acid soils, predominantly here in the Sandhills and on the coast, and in the Piedmont. In the mountains we can get some more calcareous soils, or soils that have a more basic pH. If you were to go take a superintendent's job at Sandhills in Nebraska, you would be faced with soils that have a high pH. Their lime is not going to help you. It would actually hurt you. You're going to use fertilizers or even sulfur and iron, things that will acidify the soil and bring it more towards neutral. So our soil will hold nutrients. A sand, like the sandhill soils, the soils we're going to deal with here, hold less nutrients than a clay. They have a lower cation exchange capacity. And that is one of the basic things that we will be told from the soil test. And there's our soil test report. Next time we will begin to talk about pH, CEC, and base saturation. And also I think that's it for next time. And then we'll have another video where we talk about nitrogen. And nitrogen is unique that you notice nitrogen is not on here. It's not measurable. It's a very fluid, very changing element. So most soil scientists feel it's not worth measuring. We can measure that with tissue samples, but we will talk about the magnesium index, the calcium index, the phosphorus index, the potassium index, many different things that you can get off a soil test that will help you be a better turf manager.